Today we are going to start on traffic calming concepts. By the way, all the slides for Module 3 and Module 4 I have posted both on SlideShare. So if you can go and download it, that will be helpful. So what do we mean with traffic calming? What is traffic calming measures to begin with? Traffic calming measures are physical road design elements and non-physical measures intended to reduce vehicle speeds and improve driver attentiveness. Okay, that means it's both, as you can see here in the definition. Traffic calming measures are physical road design elements and non-physical measures intended to reduce vehicle speeds and improve driver attentiveness. Of course, the objective will be to improve safety. So here the objective to improve safety and quality of life for residents by reducing the impacts from speeding vehicles, cut-through traffic, and careless drivers. يعني يا شباب الأوبجيكتيف هنا هو تحسين السلامة المرورية، تمام، ورفع مستوى المعيشة. اوكي، ده يعني مستوى او يعني درجة المعيشة في للمواطنين بتخفيض السرعة، تمام، و cut through traffic and careless drivers. Cut through traffic, those are the traffics that go through. That's the traffic that go through a neighborhood, okay, as a pass-by traffic. So what will result in? It will result in reducing speed, reduced number and reduced severity of reported collisions, reduced cut-through traffic where existing levels are significant and are and where the remedy will not create a problem on other streets. A better environment for residents and business owners as indicated by their sense of safety, property value, and comfort in using the street. So basically يا شباب هنا when we reach that objective, this is going to be the results. We are going to have slower cars, slower traffic. We are going to have the number of accidents and the severity of accidents will go down. يبقى هنا speed goes down, accidents and severity of accidents will go down, the cut-through traffic, okay, will go down, and overall it's going to be a better environment for residents and business owners as well. Okay, so these are the expected results. So back to the traffic calming measures, the toolbox. We have a toolbox of that contains different techniques and different methods of to calm the traffic and to
Sorry,
reduce.
Doctor, for interrupt you, but I have a question, please.
Yes, go ahead.
Yes, please. What's the meaning of the climbing?
Calming.
Calming.
تهدئة.
Reduce.
تهدئة. That's the actual translation. Calming is basically making things peaceful, nice, calm. Okay?
Okay.
Okay. We have non-physical measures. What are the non-physical? It includes reducing obstructions that limit driver visibility, signage, and striving improvements. This is non-physical measures. Narrowing measures. Okay, the narrowing measures basically include bulb outs, chokers, and center island narrowing. So this technique works on narrowing the street, creating sort of a small bottleneck. Okay, it's not really bottleneck, but it's just narrowing the streets. Horizontal measures, this includes traffic circles, roundabouts, and chicanes. Vertical measures includes speed humps and speed lumps. Diversion devices includes partial and full street closure. And we will talk about each of these elements from the toolbox separately. So, selecting the measure, okay, for the problem type, not all of these measures fit for all problems. So if we have a problem, there is some tools are effective, some tools are not suitable for that problem or that specific application. So that's why we have to be careful where, which measure to use for which type of problem. So here, for example, selecting measures for problem type, the major types of problems that result in a desire for traffic calming are speeding. So that's the problem type, or traffic volumes. We have heavy volume, or vehicle safety, or pedestrian safety, or noise, vibration, air pollution. Okay, that's due to motor vehicles causing excessive level of these environmental effects. For speeding, motor vehicles speeds are too high. Traffic volumes, we have high usage of motor vehicle, and vehicle safety, motor vehicles have an inordinate level of risk. Okay, so for each of these, here these are tables that we got from the source of these tables are from City of Stockton, California, traffic calming guidelines. If you need this reference, I can provide it to you for further information. So here, for example, the type of measure, okay, and this is the type of the problem, and there is a dot, a circle. If it's dark, that means it's effective. If it's half dark, half circle, okay, that means it's partially effective. If it's empty dot, that means it's not applicable for that type of problem. So we have 5 problems: speeding, traffic volume, vehicle accidents, pedestrian safety, noise. These are the 5 types that we have. And the non-physical measures, for example, targeted speed enforcement. What we mean with targeted speed enforcement, basically by having a mobile speed radar. Okay, that sometimes you see it here. It's not stationary, it's not permanent, but sometimes you apply it. When you apply it, this technique, it's effective for speeding. For vehicle accidents, it's not that effective. For pedestrian safety, not that effective. For noise, not that effective. For volume, it's irrelevant. Radar trailer, this is similar to this targeted speed enforcement. This is basically to have a trailer with a sign telling drivers, okay, what speed they are driving at. Okay, so it's good for speeding. It informs the speed if they are exceeding the speed limit. But for traffic volume, null. For speed accidents, null. For pedestrian safety, null. For noise, maybe. Speed feedback sign, that's also similar to that, but it's not in a trailer. It's kind of a permanent. Also, it's similar to the speed trailer, the radar trailer. Edge line, center line striping. Okay, this will give the driver a cue on how fast they are going, so it has an impact on speed. Optical speed bars, as you can see, not that effective, partially effective. Speed limit signage, it has direct effect on speeding, and so on. You can go all the way to, angled parking. If you allow angled parking, it forces drivers to slow speed, and also it impede the traffic volume. High visibility crosswalk, maybe it's good for pedestrians, but for speeding it's not that efficient. Cross traffic does not stop signage. This is a warning sign. It's okay. It's good for vehicle accidents. Post dots, raised reflectors is good for vehicle accidents. Truck restriction sign that prohibiting trucks. It's effective for noise and so on. So that was for the non-physical measures. That means it has nothing to do with the physical structure of the road. But when we go to the second category here, the narrowing, bulb outs and two-lane chokers and center aisle narrowing, all are good for speed. Drivers usually reduce speed. And it's also good it's partially good for traffic volume. Okay? Bulb out is good for pedestrian safety. It makes the crossing distance shorter. So this one is effective. Also, the central island is good for pedestrian safety and also good for reducing somehow vehicle accidents. And all are good for speed and partially good for traffic volume. For the horizontal measures, which mean, similar to the traffic circles, roundabouts, a single lane roundabout, lateral shifts, and chicanes. For the speed, the traffic circles and the chicanes, both are good. The roundabouts and lateral shifts are not that significantly good, but they have some sort of influence. For vehicle accidents, okay, traffic circles and roundabouts are optimum. Okay, traffic circles for road safety, it's okay. Roundabout for noise, it's efficient, as you can see.
What's traffic circles, Doctor? Same roundabouts?
What that?
The traffic circles, it's same.
Traffic circles, they are similar to roundabout, but they are not at that same level. And I will show it to you in the slides later on. Okay?
Okay.
So here for the vertical measures. Vertical measures, we mean with vertical measures speed humps, okay, speed lumps, speed cushion, split speed hump, speed tables. What we have here in Khobar, the pedestrian crossing, this is a speed table that it goes like this, going up, then staying for a while, then going down. This is a speed table. Okay. A raised crosswalk, also that's similar to the speed table. Raised intersections, textured pavement, and we will discuss each. As you can see, all of the speed humps except the textured pavement, all of these are efficient for reducing speed. Speed humps, and these all are efficient in reducing traffic volume, because basically these vertical measures reduce the capacity of the highway or the road, and we'll discuss that later. For the speed table, raised crosswalks and raised intersections, they have some partial influence on the traffic volume, but not that much. For vehicle accidents, all these measures have some partial value. But for pedestrian safety, okay, speed humps, all of these are not that efficient, but raised crosswalks and raised intersections are efficient for pedestrian safety. So these are the vertical measures. So as you can see, if we have a problem with volume and speed, we go for speed hump. If we have a problem for safety, we go to raised crosswalks. Okay? Diversion devices. Full closure, of course, if it's good for speed, reducing speed, and good in reducing traffic volume. Half closure, that means you are closing just half the way or half the road. It's good for speed, for volume. Diagonal diverters, good for speed and volume as well. Median barrier, it's not good for, it's insignificant for speed, but it's good for traffic volume and partially good for traffic accidents or vehicle accidents. Forced turn islands. It's irrelevant for speed, but it's good to reduce the traffic volume and good somehow in reducing vehicle accidents. Okay. Now the how we select based on the location. Okay, the selection criteria based on the location type. So in this table it says that these are the measures and these are residential, non-residential. So here it say put it in a mid block, and here put it in an intersection, here put it in a boundary area, and for non-residential this is mid-block, intersection. And if it has a dot, that means this is applicable. You can put this measure in mid-block or at the intersection, as you can see here. But here the X means it's irrelevant. Okay, not applicable. The dot, it's insignificant. Okay.
دكتور معلش توضح لنا الفرق بينهم بين
I will explain it to you. I will explain it to you. So here, say we are talking about residential. So if we have a street like this, so this is a street. This is intersection. This is mid-block. So here, this goes to here, mid-block. This goes to the intersection here and to that intersection here. Boundary area, that means it's on the boundary of the area. Okay? So let's take it one by one. Targeted speed enforcement and radar trailer. Okay? And even a speed feedback sign. All of these are efficient. Either way, you can put it mid-block, at intersection, or at boundary area. Edge line, center line striping. This is in mid-block. Usually it's better to have it here. But for intersection or boundary area, it's irrelevant. The same goes to optical speed bars. For speed limit signage, anywhere, it will be efficient. Truck restriction sign, of course, is going to be on the boundary. So if you want to put this, it's irrelevant to put it in mid-block or intersection because you want to avoid trucks. Okay, so you say here trucks. No trucks allowed. It must be on the boundary area. Cross traffic does not stop signage. Also, it should be on the boundary area, and so on. Here, for example, the bulb outs. Okay, the bulb out is not recommended in mid-block, but it's usually at the intersection. So here at the intersection, we make a bulb out, and I will show you a case, real case on the side, and also at the boundary area. You can have it on the boundary area here, no problem. For two-lane truckers, usually in mid-block. Okay, let me just show you what do we mean with all of these tools. This is what we mean with bulb out. Bulb out, that means we come at the street, at the end of the street, and we make this island, blocking part of the lane. Okay, to show you a better example on this, let me show you an example here. اوكي، ركز بقى معايا كده. This is what we mean with pulp out. You see it? You see this?
ايوه.
هذه مو تبع مواقف يا دكتور؟
نعم.
هذه مش تبع المواقف؟
هو الفكرة حاجة، ما احنا كان ممكن نكملها كده للآخر. خلاص، خليني أوري لك حاجة. Hold a second. أيوة. ده كان الشكل القديم بتاعها. You see it؟ ما كانش فيه bulb out وكان 2 lanes.
دكتور نزل شوي الشاشة عشان تبين، نزل شوي الشاشة.
أنزلها فين؟
زوم ان يعني.
اي اقصد زومن على تحت. ايوه.
واضحة كده؟ شايفين من هنا؟ أنت بتتفرج من جوال ولا من إيه بالظبط؟
لا، لابتوب.
Okay. You can see this is the intersection. Here this is a university. That's the North Carolina State University campus. Okay? And this is a street right on the boundary of the university. And as you can tell that there's a lot of pedestrians on this street, especially during lunch hour, because all of these streets are restaurants. Okay, so most students and faculty, they cross and go to have lunch. Okay, so that was the situation. So pedestrians, they have to cross these all 4 lanes. Okay, now they wanted to do a traffic calming, so they came up with that situation. You see it now? So now the distance that the pedestrian is crossing is significantly lower than before. And now we have only 1 lane crossing. We have parking for cars here, and this way you are forcing traffic to avoid driving through here, and if they are going to drive here, they are going to have slower speed. Okay, so that's what we mean to pulp out. Clear?
واضح ان شاء الله. يعني
وضحت
دكتور
الصورة؟
اي هذا يساعد البيدستريان ويساعد الرود يوزرز.
هو بيساعد البيدستريانز وبيخفف السبيد.
بيخفف السبيد على الرود يوزرز. تمام.
ولاحظ هنا كمان they had an island. في ايلاند فاصله
أيوة.
ما بين الاثنين، بس دي ما هياش ايلاند. خليك معايا دي واحده. ايلاند ريزد ايلاند اهي، واخد بالك؟
مرفوعه.
That's a raised island، واخد بالك؟ بس ما هيش raised قوي، يعني بحيث لو في تراك مثلا emergency vehicle ambulance or something they can drive over. Okay, and as you can see here, now the distance for crossing is significantly lower. Okay?
اوكي.
Okay. Let's go back to our slides. So you understand what it is, okay? So that's narrowing the pulp out, and that's in the middle of the road. Okay, they make this, 2-lane chokers like these. These are what we mean with lane chokers, and of course that's a splitter island or central island. Clear? So these are, horizontal measures for or narrowing. So as you can see here, that's an example for pedestrian crossing. Now they had this island. This island works as a refuge for them. So they can cross half the street. Okay, so they can, cross from here to here, then they wait here, then they continue crossing. But in the initial case, they have to cross all the way one shot. And these are traffic roundabouts. Okay, these are traffic circles, which is basically not a roundabout, but it has a circular shape like this, and this is what we mean with traffic circles. And sometimes we don't have this raised island, just painted on the pavement. Okay. So now the bulb outs usually at intersection. The two-lane chokers usually in mid-block, and it's irrelevant to put it at the intersection. And it's irrelevant to put it at the boundary area, but we can have a bulb out at boundary area. A center island narrowing. Okay, it can be in the mid block, in the intersection, and in the boundary area, no problem. For the horizontal measures, mid blocks is not recommended. Roundabouts, of course, it's not recommended. It should be at the intersection. Okay, but for the residential area, it's better to have traffic circles, because roundabouts will take, much bigger space. But if we go to non-residential, okay, roundabout is the recommended. For lateral shifts and chickens, okay, mid-block, and for non-residential mid-block as well. For vertical measures, usually vertical measures, the speed humps, speed lumps, and all these, bumps are in mid-block. We don't put it in intersection or boundary area. In non-residential, we try not to use it at all. It's not recommended. Speed tables, usually in mid-block. Okay, raised crosswalks in mid-block. Raised intersection, of course, must be at intersection or in boundary area. Textured pavement. Textured pavement يا شباب means البيفمنت نفسه we put some kind of a rough pavement, so drivers when they drive over they feel that there's some sort of a change in the sound. So textured pavement in mid block, in intersection, and in boundary area. Diversion devices usually at intersections, okay, and so on. Any questions so far? Okay, so these traffic calming measures and the traffic constraints, that means when we can use it and when we cannot use it. So, for example, for the targeted speed enforcement and all of these non-physical measures, this is valid for average daily traffic volume less than 10,000 vehicles per day. And the speed limit, okay, should be less than or equal 35 miles per hour. Bus or emergency response route, it's okay, no problem.
يعني كم بالكيلومتر يا دكتور تقريبا؟
Multiply by 1.6.
Okay.
So that's almost 56 or 60 kilometers per hour. Up to 60 kilometers per hour, this is not, this is acceptable. Above that, it's not recommended. It's not, it's inefficient. Can we use it on bus route or emergency response route? Yes, okay. Is there any other consideration? No. For angled parking, we can use it for average daily traffic volume less than 4,000 not 10,000 here. The width must be greater than or equal 48 feet. The speed limit less than 30 miles per hour, and don't use it if we have a bus route or emergency response route. يعني لو ده على طريق فيه باصات او طريق بتاع emergency يعني emergency response, okay, don't use the angled parking because it has the potential of blocking the route or blocking the street. Okay, bulb outs, narrowing measures. The average daily traffic volume should be less than 20,000, speed limit less than or equal 35 miles per hour. On bus route or emergency, yes, no problem. 2-lane chokers, the same, these are the conditions. This is okay. Okay, Central Islander, that's also the same. Okay, there's another consideration also on bike routes designed with clear bike accommodations. يعني في الطرق المناطق اللي فيها bike routes, you have to accommodate bikes. For example, in the example here, I think this, I'm not sure if this was open for the bikes or maybe for drainage of storm water. For the traffic circles, for local streets, if the volume is less than 70, the volume must be less than 7,500 and the speed limit less than 35 miles per hour. For non-residential collectors, residential collectors may be required at intersection where residential collectors streets intersect with local streets. Bus or emergency route, yes, okay, no problem. Grade less than or equal 10%. Roundabouts for daily entering volume less than 20,000. That's in based on road for all roadway classifications, less than 20,000 vehicle per hour, and the speed limit less than or equal 45 mile per hour. 45 mile per hour, that's almost to, equal to 80. It's 72 kilometers per hour. And here must design inscribed radius to be 100 plus feet. يعني inscribed diameter يكون أكتر من 30 متر. Okay? And the grade must be less than or equal 6% on bike routes. Okay? Lateral shifts and so on. So we can see here, for example, the speed humps and all these speed bumps are average daily traffic volume less than 4,000. The speed limit less than or equal 30 miles per hour. For bus or emergency route, speed hump is no, as you can see. But speed lumps, speed cushion, speed humps are split speed humps are okay. Speed tables, this is the volume criteria, and speed tables, raised crosswalks, raised intersection, all are similar sort of. So but here it says that the average daily traffic volume less than 7,500, and it's okay on emergency routes and buses. And similar here also. We're gonna skip this one. So these are this is what we call the narrowing bulb outs, and here this is the narrowing 2-lane chokers. As you can see, these are the chokers. So it's basically reducing this lane width available for vehicle to drive through. And narrowing measures, okay, with having a central island. This is good for pedestrians, as I mentioned, to go and cross stop here, then they continue. And actually, I think this is a raised pedestrian crossing. So in this we have two measures. First, the narrowing measure, okay, and the raised pedestrian crossing. As we explained before, then that's the roundabout. Of course, roundabouts force drivers to reduce their speed. As you can see, the route it used to be like this. But now the driver must go in like this, then turn, then continue. You know, these force drivers to slow down their speed. That's a traffic circle, as I mentioned before. The traffic circle doesn't have the same elements that we have in a typical roundabout. Okay, so in typical roundabout we have the entry line, we have the splitter islands, okay, we have the pedestrian crossing, we have the angled for forced speed reduction. All of these are associated with roundabouts. But for the traffic circle, this does not apply. Okay. Then there's the horizontal, one of the lateral shifts, as you can see. That was a straight road, okay, but they took from the sidewalk here, and so they are forcing drivers to make a slight turn in their vector. So this way they forced them to slow down. These are chicanas, and actually these are the ones, okay, and from my perspective I don't think this is relevant to use in in our case. I don't know how effective these are, but these are used in California most probably. That's another form of the chicanas, okay, here. So it's forcing drivers to not to go straight, but sometimes it might be confusing and might generate accidents, so you have to be careful making a recommendation for something like that. These are the non-physical measures that you put a sign with a radar, okay, in a microwave radar, and it gives feedback for drivers on their speed. This is the speed trailer, which is basically a trailer with a standalone trailer, and it shows the speed limit and your actual speed. These are the striping and the pedestrian crossing. Here, these are also some of the traffic calming or non-physical measures. This is a speed bump. Okay. That's vertical measure. That's a speed hump. Okay. The difference between speed bump and speed hump, the distance. The speed bump is like this. The speed hump is smoother but longer. Okay. This is an example for speed table. Also, pedestrian crossing table, okay, can be used here. So that was for the vertical measures. Now with the divergence measures. These are the measures that force traffic to diverge and not. So this is basically intended to cutting the through traffic. Okay, so in this case, that's full closure. This is partial closure. That means vehicles can come exit from here, but no vehicles can enter from here. But this is an exit only lane. sorry. And there is the diagonal closure. That means the intersection like this, and basically we put a closure here. So the traffic will go this way, you see the point? So this is basically good in cutting through traffic. يعني الوسيلة دي يا شباب ممتازة في وقف السيارات اللي بتدخل من الكتل السكانية عشان تختصر مسافة أو عشان حاجة زي كده يعني. واضح؟ There is the median barrier. بمعنى إن هنا مثلا كان الميديان كانت مفتوحة، ما كانش فيه ميديان، فاللي كان عاوز يلف جاي بيلف على طول يدخل. This caused perhaps maybe it caused accidents, it's risky, so they put a median and you must go and make a U-turn from here, then you go and make right turn. So this by having median barrier. This is another example for partial closure. So you have only exit, no entry. Okay. Any questions so far? Okay, we're gonna have a break and we're gonna stop and come back later.
اوكي.
So now we are gonna start on discussing the making an assessment for some of these tools. So we're going to start with assessment for the speed hump. How does it impact the capacity of the facility that we have? So for example, if we look here that we have a speed hump, and usually speed humps are designed such that it will, enforce certain speed reduction. Okay, so speed humps are common traffic calming techniques that is being used in several cities or all over the world. The main objective of speed humps is to reduce the speed of the traffic. And however, it has a serious impact over the overall capacity of the approach. That's so we need to quantify how much, its impact on the capacity. And we will show that. Basically, the dotted line, this is the flow density, that's the flow rate, and that's the density. The flow density diagram, and as you know, it's parabola. So in this case, the dotted line, that was the original for the facility, and the solid line, that's right above, over the, or at, so this is right at the speed hump. As you can see, there is a drop in the capacity. Basically, because there is a drop in the speed. That was the slope here, that's the speed over the speed hump. And here, that's the speed at saturation when there was no speed hump. So there is a significant reduction in capacity. So basically, if we look into the diagram for the speed density diagram, if we say, for example, that we have a speed hump that is designed, for example, to have a drop to 25 kilometers per hour. So basically, that what we are going to end up with. So the original, it was 75 at level of service C, so it will go down to that point. Okay. Of course, actually, it will go this way. It will be in F. So that means, okay, let me just clear this. For example, if we have a condition, and that's the level of service for a facility, or that was the level of service for the facility, and that's the current LOS. Then we added a speed hump that reduced the speed down to 25 kilometers per hour. So what do we have here? We have F level of service. Okay, this is not acceptable. That means instead of doing that, the maximum we can reduce the speed without getting to the F is basically going here. And even if we reduce the speed to this level, 50, that's almost D. So this is still acceptable. So we have to be careful with selecting the speed control measure such that we don't turn situation into an F situation or congestion. So we are treating, solving a problem but creating a problem on the other end. The same applies also for the narrowing approach, the narrowing strategies. We need to be careful with that. So here we have an example: impact of speed hump on capacity and level of service operational case, existing facility. Study the effect of adding a speed hump on level of service and the overall capacity of the following approach. Number of lanes 3, lane width 3.4, median yes, shoulders 0.6, traffic volume 1275 vehicle per hour, and topography, the terrain, level terrain, and the percentage heavy vehicle is 12%, peak hour factor 0.9, access 0.6 access points. So let's try to solve this. Number of lanes, that's in each direction. So here we have 3 and we have 3 on the opposing direction. So I'm not sure if that's correct, but anyway. So let's see the free flow speed. The observed speed is 70, so this will be the basic free flow speed. So the basic free flow speed is 70 minus the lane width is 3.4, so we need to adjust for that. So basically the free flow speed will be 70 minus adjustment factor for lane width, minus adjustment factor for lateral clearance, minus adjustment factor for median, minus adjustment factor for access point. So the free flow speed will be 70 minus the lane width we have here 3.4 meters. So this will be, we will need to have an adjustment factor for that. For 3.4 we have 2.1 adjustment factor. So here minus 2.1. Lateral clearance we have 0.6 shoulders. Okay, and the median, yes, we have a median. Okay, so we're going to assume that we have 0.6 and 0.6, 1.2 total lateral clearance. So the total lateral clearance 1.2, we have reduction in free flow speed in case of 4 highway, 3 for 6 lanes, it's 2.7. So this is 2.7. Median, we have a median, so there is no reduction factor. Access points, we have 6 access points, so the 6 access points accounts for minus 4 kilometers per hour. So this is minus 0, minus 4. So this will be, the free flow speed would be 61.2, I'm sorry, So the free flow speed will be 61.2 kilometers per hour. The VP equal 1275 divided by peak hour factor 0.9 multiply, we have 3 lanes, so we have 3 in both directions, okay, multiply the factor for heavy vehicle. The factor for heavy vehicle FHV equal 1 over 1 plus 0.12 multiply 1.5 minus 1. So this will be 0.12 multiply 0.5 plus 1, 90.94. So this is 0.94 multiply 1 equal. So this multiply 3 multiply 0.9 multiply 1, 275. So we have 500.55 passenger car per hour per lane. So the density will be 500 divided by the speed, which is 61.2. So we have 8.18 passenger car per kilometer per lane, which means we have a level of service, I believe this is near A almost. So that's the density here. Yes, it's B. It's between these two values, so it's a B. So it's a B. See now, when we have a reduction, okay, a potential drop in the speed, according to here, it's 40 kilometers per hour. So this is going to be operating as 20. This is going to be 20 kilometers per hour or 21 kilometers per hour. Let's see the new density, how it will be. It will be 500, the same traffic volume didn't change, but divided by 21. How much density we will have at that speed hump? 23.6 passenger car per kilometer per lane. So here now we have a new level of service, which is E. As you can see, this is sometimes not acceptable. And also, you need to drop the speed, but not with this magnitude and not down to this level. Okay? Basically, ya shabab, we try to minimize or reduce the speed such that making intersections safe, forcing drivers to not exceeding certain speed value. So there are several considerations for this. You know, for example, there was a speeding problem in a residential compound, and I was asked, you know, as a consultant to make recommendations. So I usually, you know, what I did, these are the intersections, and there was long segments like this. So once we reach to the point that the driver can accelerate and get to a high speed, we put a speed hump, such that we force the driver not to you know, he must slow down to cross this, then he can, you know, then we have another speed hump here. So this way you are forcing the driver, and of course this distance, I think it was 800 meters. So we had to make this configuration. Any questions so far? Okay, Shabab, I think that will conclude today's lecture, and see you next time, inshallah.